Hello guys, welcome once again to another YouTube tutorial on bioinformatics. Today's tutorial, I'm going to show you how to perform genome annotation using PGAP. PGAP is an NCBI pipeline, and if you want to read more on it, you can just go to the home page of NCBI and then read on how it's set up. Okay, there's also a short video for you to learn quickly about how it's used as well. In addition, there's an extensive documentation on the GitHub page, okay, that gives instructions on how to also install PGAP and then configure it as well. So for this tutorial, I'll follow these instructions here as well to set PGAP up. Now, in terms of the minimum requirements, okay, it's required to have this conditions satisfied before running PGAP. Okay, so you should have Python 3.6 or higher version installed, and you should also have the ability to run Docker, okay, or Singularity or Podman. In this tutorial, I use Singularity. Okay, now you should also have 100 GB of storage space, and this is needed because during the annotation process, PGAP generates files which can take up some level of space. Okay, you should also have 2 GB to 4 GB of memory available per CPU. And in my experience, I would recommend that the PC you'll be using should have at least 8 CPUs, and then the RAM or memory should be at least 32 GB, is to avoid going into certain issues. Your CPU should also satisfy this condition here as well. Now for this tutorial, this is how we are going to do it. So you should install libarchive-dev if you are using Ubuntu. I had that prompt, so I installed it when I was using Ubuntu. When using CentOS, I didn't have that prompt, so it's okay. Python 3.6 and then Python 3 pip should also be installed, and then using the pip, you install CWL2. Then you should also have the Go programming language installed. Okay, so there's a binary version available that you can download and set up quickly. And then you should also have this tool installed. Okay, it's very important you have it installed as well. You should also have Singularity, which I've talked about. And then once you are done, you download PGAP as well. It's also important that your ulimits should be set to a minimum of 8192. Okay, in my experience, anything below 8192 made PGAP to fail. So ulimit is the file limits, the number of files opened when running an application or a process or whatever on a Unix platform. Okay, so if you are running on a cluster, you can ask your system admin to increase the file limits for you. You should also be able to check it, and we will do that as we proceed. So once you are done with the PGAP setup, you need to have your input files ready. Okay, so the input files, you need to have a genome assembly sequence file. This is a file you are going to annotate. So if you've not watched my genome assembly video tutorial, it's right here and then you can watch. So the genome assembly will generate context for you. You can also use scaffolds or reference guided scaffolds to perform the genome annotation as well. In addition, you should have the submo YAML file. So this file provides information that will be used for annotating your genome. Okay. Now, what happens is there are lots of information you can actually add here, but the only ones that are required by PGAP is the organism name. So that's the species and then the genus. Those are the only ones required in the submo YAML files. All the other ones are optional. And the third one is the generic YAML file. So this file provides paths to the genome assembly file and then the submo file. So paths for the submo YAML file and genome assembly should all be placed in this generic YAML file. So all these three files are needed in order for PGAP to run. Okay, so now we can hit the terminal to begin the process. So before we start, let's create a directory where we will perform all our activities in. So the first thing you have to do is to download the pgap.py file from the GitHub page. Okay, so that's what we are going to do first. So let's check, and it has been downloaded. Okay, now let's clear the screen to make it nicer. The next step is to make sure you've added execution permission, execution rights to the pgap file. Okay, Linux by default disallows execution, so we need to allow it. Oops, syntax error is this. Yeah. There is the actual command for allowing execution. Okay, so once we are done with this, we can now update. So for the update, if you already have some database, to update it. If there is no database available, then it downloads everything for you. Okay, so you execute with Python 3.6. Okay, but because I'm using Singularity, I'll have to specify the full path to the Singularity executable file. So I do that, and this part might be different from yours if you are setting up Singularity. So you need to check for the exact file parts and use it there. So once you set it up, then you issue the update flag to proceed. So download will now start. Now the database is large, I think it's greater than 30 GB, and so it needs to have some faster bandwidth as well to download. Great. So now we have the PGAP database successfully downloaded. Okay, but take note that it takes a while to download because of the size. Let's confirm here. Okay, let me just redo that command. Okay, so you realize that aside the pgap.py, we also have this image downloaded, and then we have this inputs. Okay, these files. Okay, we will skip the testing. I'm assuming that everything had gone on well, so we'll just proceed. So once you have the PGAP successfully installed, we are now ready to run our genomes. So first of all, let's check the input files. Great. So let's check the input files. You're supposed to have 3 files. So here I have my 3 files here. So I have my genome assembly file, and I also have the generic YAML file here, and then the submo file. Okay, so This will be a faster file for the genome assembly file. And then we also need to have the K45 input YAML. That's the name I've given it, K45, but it's the input YAML file. Okay, so let's look at the SAML one first. So the SAML YAML file has information that we need. That's the name of the organism. Okay, so first of all, what you need to do is to have a topology of the organism. Is it circular or is linear? So the organism I'm dealing with is circular, and so I specify circular here. It's very important. Okay, so we need to specify the topology as I said, so it's circular. Let me put it in quotes. And then another thing we need to indicate is the location. This is very important because sometimes you might want to be annotating plasmids, but this one is chromosome, so we specify the location as well. And then we come to the organism. So the organism name, I'm dealing with Mycobacterium ulcerans, so I specify that here. So we have the genus species. So this is how you enter the metadata SAML file. Okay, it's very important you get to know this particular one is yes. So this is for the second file. So once we are done with this, you can save it. There we close. Now the next one is the generic YAML file, which has locations to the SAML file as well as the assembly file. And so this is the format for specifying it. Okay, so you need to integrate a faster. That's for the genome assembly, and you indicate the class, which is file. And then you also need to indicate the location, which is the K45.faster. That's the name of the file I gave it, as you can see here. Okay, so it's the exact same name you give it. And then you move to the SAML section. You also indicate the class, which is file, and then the location, which is the K45.saml.yaml. Okay, so these names should be the same as the file names you use to name them. Okay, so this is for the other file. So once we are done with this, we have all the files and all the labels needed, so we can proceed with the annotation process. So before we run, let's look at the PGAP syntax. So the syntax, we run Python, and then we specify the pgap.py. Then we specify the path to the singularity using the -d. And then we also specify no internet flag. Now this particular one is optional. So when you don't specify, PGAP also searches online for additional information. Okay, that has to do with the database it has online. But if you don't want that, you can just use the no internet and it will only use the database locally. So no internet is it's supposed to, it makes it faster because PGAP doesn't check online for updates on its database before doing the annotation. So for example, as we've already done our downloads of the PGAP database now, there's really no need to search online again for updates because this is the current updates we have. So that is why no internet is given. It also makes it faster, as I said. and then we have the -r flag, and then the -d flag, and then after that we specify the -o, which indicates the output directory, which folder name PGAP should use to save the annotation, okay, the annotated files. And then finally we specify the generic.yaml file. So once you are done with that, then PGAP starts loading. So now let's quickly go and then do the activity on the terminal. So I have my files ready and they are here. Okay, so these are my files. So I will now specify its PGAP to do the annotation. So here we go. Specifying the path to singularity. And then we indicate with a -r flag, the no internet flag, then -d-o. Then we indicate the output directory. The output directory, you should make sure it doesn't exist because PGAP will create it. So let's say K45 annotate. And then finally we'll specify the generic YAML. In this case, my file name is k45.input.yaml. It's also important that you have all those three files in the same location as where you download the PGAP database so that you don't have any issues as you run. So once we are done with this, we now hit enter. Okay, so PGAP will start doing the annotations if all the parameters are okay. Notice that it indicated that we've specified no internet flag, so it wouldn't check for remote versions. Okay, which is okay because we already have the current version. And so depending on your computing power, in terms of RAM and in terms of the CPUs, PGAP will take some time to run. Okay, so you have to wait for it until it's done and then you can check the files afterwards. So let's just wait while it finishes the annotation. Okay, so now the annotation is done. Bear in mind that the annotation can take a while before it's completed based on your computing resources. And so we can check the directory where the files have been created. So this is the folder which has the annotated files. So we can cd to it and find out what is there. Let me clear first. Okay. So after the annotation is done, these are the files that will be generated. Okay. But the annotated informations are in this particular ones. And then these ones. Okay. So this is just a debug information which depending on your questions you might want to just go into it, but usually you can discard these ones off. So this contains the annotation, that's the GenBank format, which has some information as well, and then FE, FNE, GFF, So depending on your questions, you can proceed to further do some analysis with using any of these files as well. Okay, so that brings me to the end of my tutorial on annotation using PGAP. Then I'll see you again another time. Bye bye.